What is the API gateway pattern? So, the API gateway pattern is a design pattern in microservices architecture that acts as a single entry point for all client requests to the backend service of an application. It's used to manage, route, and orchestrate communication between clients and backend services, often providing additional functionalities like authentication, security, load balancing, caching, request shaping, and management. Let's talk about the purpose of the API gateway. Let's delete all of that and start fresh. The first thing that we'll talk about with is the aggregation. The API gateway con- consolidates multiple individual services or service calls into a single call to simplify the client's interactions with the microservices. This is especially useful when a client needs data from multiple services to complete an operation. Number two, abstraction. It it abstracts the complexity and on distrib- distribution of underlying system. The client interacts with one endpoint, which is the API gateway, which handles the communication with various microservices. Number three, we have cross-cutting concerns. So handle cross-cutting concerns such as authentication, SSL termination, logging, and security. By centralizing these functionalities, individual services can remain focused on their specific business logic. Let's talk about the key components and features of the API gateway. The first thing that we'll talk about, which is quite obvious, which is routing. Routes requests to the appropriate microservice based on the API path or other attributes in the request. This involves resolving which service should handle the request and forwarding the request to the service. Number two, authentication and authorization. Often in incorporates security measures to authenticate and authorize requests before routing them to backend services. This might involve integrating with identity providers, validating JSON, JWT or JSON Web Token, and etc. Number three, rate limiting and throttling. They can enforce rate limits and throttling policies to prevent any single consumer from overloading the backend services. This is crucial for maintaining the stability and availability of the services. Number four, load balancing. We have it distributes incoming requests across instances of services, improving the fault tolerance and response time of applications. Number five, we have caching. We improves the performance of requests by caching the response of operations that are expensive and whose results and do not change frequently. Number six, which is fault tolerance. It implements pattern like circuit breakers to manage failure in service dependencies gracefully. This helps to prevent cascading failures when a service is down. And we want to talk about response transformation. We manipulate responses from services before they are sent to the client. This can include aggregating responses from multiple services, filtering data, and converting between different data formats. Lastly, logging and monitoring. It provides centralized logging and monitoring requests and responses, which is essential for debugging and tracing issues across microservices. Let's talk about the implementation considerations. The first thing we want to talk about the complexity because it's really complex. So implementing an API gateway can add complexity to the system architecture. It becomes a critical point that must be managed and maintained properly. Performance as a center point through which all external traffic flows. The API gateway must be optimized to handle high loads without becoming a bottleneck. Number three, we have reliability. So it needs to be highly available and resilient since it is the entry point for all requests. Failure in the API gateway can result in the failure of the entire system from the client's perspective. And lastly, we want to talk about the scalability. So should be able to scale, accommodate growth in traffic. This often involves deploying multiple instances of the gateway and configuring them behind a load balancer. So, some popular tools and technologies that provide API gateway functionalities includes Amazon API Gateway. We have Kong. We have Zool, which is ZUUL. These tools offer built-in support for many um, of the mentioned features and are widely used in the industry for managing microservices-based architecture. So, in summary, the API gateway pattern is essential for microservices architecture, providing a unified interface to clients while handling a variety of concerns that are common across services, thereby simplifying microservices management and enhancing client interactions. So that's it for this video, and see you in the future.